Welcome to the Walton Pi. Today we're going to be talking about premeasures and their induced outer measure. So a premeasure on an algebra A is going to be a function mu naught from A to the interval 0 to infinity, where it's able to attain the values of 0 and infinity that satisfies the following properties. First, mu naught of the empty set is 0. And secondly, if a collection of AIs is pairwise disjoint and the union of the AIs is in our algebra A, then mu naught of the union of those AIs has to be equal to the sum of the mu naughts of the AIs. Note that this definition of a premeasure allows for it to not always be a measure. If the algebra A was a sigma algebra, then it would be a measure, but it's not guaranteed to be a measure because we don't know for sure that A is going to be a sigma algebra. We just know it's an algebra, so we have to pay attention to that. It's not always a measure. I've been tripped up by this before. I'm just mentioning it so that hopefully you don't get tripped up on this in the future. So yeah, a premeasure is not always a measure. So let's talk about a quick proposition. If mu naught is a premeasure on A and mu star is the induced outer measure, then mu star is going to be an extension of mu naught and A is a subset of the mu star measurable sets. So let's fix E in A, and then consider E to be the set of AIs, where A1 is E and AI is empty for all i's bigger than 1. Then that means that E is contained in the union of these E's, and so then that means that mu star of E is less than or equal to the sum of mu naught of the AIs. Since all of them are empty except for 1, we just get the mu naught of E. So mu star of E is equal to mu naught of E. Oh, well, it's less than or equal to. We're not going to show it's equal. Now fix the sequence of AIs with E being contained in the union of the AIs. Then E is the union of the E intersect AIs, which is equal to the union from 1 to infinity of the E intersect AIs minus the union of the AJs, where J is less than I, which is an element of A. And since mu naught is a premeasure, mu naught of E is equal to the sum from 1 to infinity of mu naught of E intersect AI set subtraction of the union of all j's less than I of AJ. This is less than or equal to the sum from 1 to infinity of mu naught of AI. So that tells us that mu naught of E is less than or equal to the infimum of the sum of these mu naughts of AIs, which is equal to mu star of E. Thus, mu star of E is equal to mu naught of E, because we have now gotten both directions of the inequality. Now recall that a set E is mu star measurable if and only if mu star of T is less than or equal to mu star of T intersect E plus mu star of T minus E, which is less than or equal to mu star of T. In other words, we have equality. Specifically, we have to prove the second inequality because the first is an immediate result of monotonicity. So note that if mu star of T is infinite, the second equality is clear. Infinity is definitely bigger than whatever two values you add together, even if one or both is infinite. So we only have to deal with the case where mu star of T is finite. So let's fix A in A, T a subset of X, and epsilon bigger than 0 with mu star of T being finite. Choose a family, BIs, as a subset of A, with T contained in the union of the BIs, and then mu star of T plus epsilon is bigger than or equal to the sum from 1 to infinity of the mu naughts of BIs. Since mu naught is a premeasure and T minus A is contained in the union of the BIs minus A, we are able to get that mu star of T plus epsilon is greater than or equal to the sum from 1 to infinity of mu naught of BI minus A plus mu naught of BI intersect A, which is equal to the sum from 1 to infinity of mu naught of B minus A plus the sum from 1 to infinity of mu naught of B intersect A. These are pairwise disjoint sets, so we're able to break them apart and preserve equality, which is greater than or equal to mu star of T minus A plus mu star of T intersect A. Thus, mu star of T minus A is the infimum of these epsilons, which is less than or equal to the sum of the mu naughts of BIs minus A when mu star of T is finite. Since the infimum of all epsilons bigger than 0 is 0, we end up with equality, and our proof is complete. I hope this video was helpful. If it was, please like and subscribe. It really helps me to make more videos. Check out the comment section and leave me whatever videos you would like to see me make next. Have a great rest of your day and good luck with all of your math.